Hello everyone, my name is Greg and I dev stuff. Welcome everyone to episode 5 of Stardew Valley-like game in Unity. In this episode we will implement an inventory system. Let's clean our root folder. Before we begin, big thanks to all my Patreon supporters. If you want to support further, link to my Patreon in the description. We need to build an inventory GUI on the screen first. As always, for the visual stuff, we go to OpenGameArt website. The link to the art asset, which will be used in this video, is in the description. Please tell the artist that he is an amazing, as always, I always say that we should appreciate everyone who does this amazing job, especially share their art for free. When you are done downloading this pack, you will find that there is a folder called Spritesheet. Drag and drop the Spritesheet into the Unity. Make sure you turn off the texture filtering to avoid them looking blurry. Slice the UI. This one will be used as a base for inventory window. And this one for inventory slot. Good. Now we need to build the UI on the screen. So create a new panel called Inventory Panel. Assign the background as a sprite for this panel. Let's anchor it in the middle and try to launch it. And now you can see it looks ugly. This is because we are stretching this object too much, and because of that it looks pixelated. To solve this issue we need to use what Unity calls 9 slicing sprite. 9 slicing is a 2D technique which allows you to reuse an image at various sizes without needing to prepare multiple assets. It involves splitting the image into 9 portions, so that when you resize the sprite, the different portion scale or tile, that is, repeat in a grid formation in different ways to keep the sprite in proportion. This is useful when creating pattern or texture, such as wall or floor, or in our case, UI elements. Select the sprite sheet and make its mesh type as full rect. Now if you open the sprite editor, you will be able to set the borders of your 9 slices sprite. After you are done setting up those borders, you will see that you replace the reference to the sprite, our object scales way better. It is because on 9 slice sprite, Unity doesn't scale corners and only stretch borders on one axis. to not make the borders look fat and overstretched. The small spikes does still looks not that good, but we can either edit them out later or replace whole texture later. Good. Now let's place a button on this panel to represent the inventory slot. The moment we are satisfied with the size of the buttons, let's replace its icon with the button icon. Prefab the button and rename panel to inventory panel. Now we can select our button and start copying them again and again and again until you fill the whole space. But this is quite, well, not productive. One of the most important wise words I heard about programmers is that the lazy programmer is the best programmer. You should try to make everything as automatic as possible. The less time you spend copying and placing objects on the screen, the better. So how can we do this in the context of Unity and grid of buttons which represent the inventory? Select the inventory panel and add grid layout group component. This component will place all the child objects of this panel in the grid-like manner. In the grid layout group, change the size of the cell. Add spacing between each cell and add some padding to the grid layout. After this, copy necessary amount of slots. We can read the size of the inventory later and automatically create the amount of button equals to the size of the inventory. But for now, let's just simply do it this way. We will come back to this later. In my case, I decided to go for 36 total amount of slots. So I created 36 buttons. Good, we're done with the layout for our inventory for now. Now we want to introduce some kind of way to store the data about your items in the game. To do this, we will utilize something called scriptable objects. A scriptable object is a data container that you can use to save large amounts of data, which is easily serializable and easily editable in the Unity editor. So, create a new script called item and open the newly created script. Inherit from the scriptable object in the item script. Now to be able to create an instance of the scriptable object, we need to add an attribute to the class called createAssetMenu with the menu name parameter. Inside the menu name, you define the path for the option to create an instance. Inside the item class, let's define variable for it. For now, let's add string name, boolean stackable, and sprite icon. So now in the editor, if you create an instance of the item, you will see those variables available for you to edit. You can create multiple instances of this scriptable object for all kinds of items. Let's create a stone, wood, and sword item. Now we need some kinda icons for those items. I found pretty good looking icon pack on OpenGameAsset, which you can find in the description. Because I don't have a good looking wood, we will use a staff as an icon for wood, for now. Good. Now we filled our game with items data, but now we need to add those items into the actual gameplay. We begin by making our inventory, but we will use a somewhat unconventional technique for the inventory. We will use a scriptable object once again. Create a new script called item container and inherit it from scriptable object. Add create asset menu attribute. And then let's create a new class which will be storing the reference to the item we are storing in our item container. Create an integer variable for the count of stackable items. Then declare a list of those item slots in the item container. Now in the editor you can easily add and edit the amount of items in the slots. And I edit items stored in those slots. Let's add the amount of slots you have in your inventory. So in my case it's 36. Good. Now we have items and the container which can store those items. Now we want our inventory panel be able to read this list of items and show them in the inventory panel. Select the inventory panel and create another new script called inventory panel. Define the reference variable to the item container which will be storing our inventory. We need some kind of way to update our panel state. For this, create a new method called show. Go back to the editor and let's modify the inventory button prefab. Let's redesign it a little. Double click on inventory button prefab in the project. Add image for the icon and modify text to represent the amount of stackable items stored in this slot. Select the inventory button and create another new script called inventory button. Inside the script, create two serialized references to the image and text. Create my index variable of type int. We need some kind of way to set up the index of the inventory button. So create a new public method called setIndex with the index as a parameter. Inside, set the index. Create one more public method called set with item slot as a parameter. Inside this method, we will set up our item to show on the screen. So set the icon to the image. Then check is our item passed in the item slot is stackable. And in case it is stackable, set the count to our text. Hide the item count in case the items is not stackable. Then create a new method called clean, which will remove sprite, then hide icon and text. Go back to the editor and assign the reference to the text and icon on the button. Exit prefab editor and you will see that this updates all the instances of the prefab on the scene. So every time you want to edit the prefab, do it through the prefab editor rather than on the scene. Assign the inventory on the inventory panel and then open the inventory panel script. Create a new method called setIndex and cycle through your inventory and set the index on the buttons. Oh yeah, we need to create a serialized list of those buttons so we will be able to reference and call them when they need it. Then in the show, cycle through your buttons and set or hide them based on the inventory. If in the inventory slot there is an item, set it into the button. If there is no item, then call clean on the button to hide what this button contains. Let's test this. Yes, I forgot to add buttons to the list, as usual. As you can see, I can add items and it will change the inventory after I restart the game. Let's make it possible to close and open the inventory. Select the character and create and add a new script called inventory controller. Inside, add serialized GameObject panel and inverse the active state if you press I in the update. Of course, as usual, I forgot to add the reference to the panel. Now let's expand our drop system. You remember that when we cut down the tree it dropped logs of wood. When they reach the player, they should be added to the inventory. So open the item container script. Inside we want to define all methods which we will use to interact with this container. We need a method which will add the item to our item container. So create a new public method called add, with item as a parameter, and count of those items with default value of 1. Inside this method we need to determine is this new item stackable. In case it is not stackable, simply find first empty slot and insert item into the slot. Because of not no check, if there is no empty slots in the item container, item will not be added to the item container. If it is stackable, check if there is any items of this type in the inventory by comparing the item, and if we already have one, add the count to the slot. If not, add a new item to the slot. Then open Game Manager and add a new public field called Inventory Container. Assign the reference to the inventory. Now open the pickup item script. Here, when our item reaches the player, we want to add it to the inventory. So define two public variables of type item and count. Make count default as 1. And write those parameters into the add call. Let's test this. Good, as you can see, the system has one big benefit. It stays persistent, even after restarting the game. So it is safe to say that scene-to-scene transition will not be an issue. This means you already have a saved inventory in your memory. You don't need to rely on the XML or, God forbid, player prefs for the save load algorithm. And you can edit the state of your inventory on the fly in the editor. One last thing for today. Every time you want to clean the inventory, you have to go through each of those slots and nullify them by hand. We want to make it easier for ourselves. To do this, we will create a custom editor for the item container. Create a new folder called editor. Every script which inherits from the editor class must be placed into the folder. No other script should be placed there, especially monobehavior or scriptable objects. Create a new script called item container editor. Open it. Inside inherit from the editor. Override the onInspector GUI. Inside this override we can draw our own inspector. For now we want to add a simple button which will clean out the item container. First we want to call drawDefaultInspector. This will draw what you can already see in the inspector. After this we want to create a GUI layout button, and inside cycle through the container and clean its slots. In the next episode we will expand on this system, making inventory more interactable. Good, this is it for this episode. If you have any questions or any ideas about code, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. With best regards, see you in the next episode.